This is our Pre-Algebra 1 summer work, week number 1. You are expected to do the odd problems. I will be working some of the odd problems with you. Pause the video between each problem to try on your own. Number 1 here we have -5 minus -4. Remember, when we are dealing with subtraction, we will change that subtraction to an addition and change the sign of the number behind it. Thus, we change this to -5. The first number stays the same, -5. The subtraction becomes an addition, and the second sign changes. -5 minus -4 is the same as -5 plus 4. When we're adding and the signs are different, subtract the numbers. The larger absolute value gets the sign. The sum here is -1. This makes sense. If you have 5 negatives and 4 positives, the sum would be 1 negative. You can think of a negative number like owing money. If you owe $5 and then somebody gives you 4, you would still owe $1, wouldn't you? All right. Number 3, -1 plus 3. When the signs are different, just subtract the numbers. Don't worry about the signs. 3 minus 1 is 2. Is it positive or negative? Well, whatever there are more of, that's the result. There's more positives, so the result, the sum, is positive. If you owed $1 and you gained $3, you would really have $2. You would have to pay back one of those dollars. 3 minus -8. We change our subtraction to an addition and change the sign of the number behind. -8 becomes +8. Using our negative numbers like owing concept, if you subtract, that is, take away owing money, isn't that like giving you money? If you owed me $8 and I said, hey, you no longer owe me $8, isn't that like giving you $8? Makes sense. 3 plus 8 is 11. 3 minus a -8 is a +11. Well, if the signs are the same and we're adding, we simply add them up and keep the signs the same. This makes perfect sense. 4 negatives and 1 negative is 5 negatives. If I owe $4 and I owe $1, don't I owe $5? Okay, here we have a subtraction again. Change that subtraction to an addition, change the sign of the number behind it. -4 minus 3 is equivalent to -4 plus a -3. 4 negatives and 3 negatives is 7 negatives. If you owe $4 and you take away 3 more dollars, you really owe 7. Okay, find each product. Product is the result of a multiplication problem. When I say 4 times 3 is equal to 12, these things we multiply, they're called the factors, the parts of a multiplication problem. The result, 12 here, that's the product. All right. Multiplication, division, very easy. If the signs are different, the result is negative. -10 times 6, -60. If the signs are different, the result is negative. 8 times 7, 56. Negative times positive, negative. If the signs are the same, the result is positive. 4 times 7 is 28. A negative times negative is positive. When the signs are different, the result is negative. Signs are same, the result is positive. -5 times -5, +25. Solve each equation. What we're looking for is the solution. A solution is a value that makes a statement true. This is a primary fundamental definition in algebra. A value that makes the statement. Okay. So we have -13 equals p minus 19. We can substitute anything in the world we want for p, but it turns out only one value will make this statement true. So I want to get p by itself. Currently we have p minus 19. I want to undo that minus 19. Just drawing a little separator line like a fence right down the middle of my equal sign. I want to undo minus 19. I use the inverse operation, add 19. Whatever do to one side, I do to the other. minus 19 plus 19 sums to 0, leaving only p equals in the middle. Negative 13 plus 19 will be 6. I believe this is the solution. I must take it and substitute it back in. So I'm restating this. Negative 13 equals, instead of p, what we think p to be, 6 minus 19. Well, what is 6 minus 19? That's 6 plus negative 19. And 6 plus negative 19 is a negative 13. The left side we have negative 13. So we're left with this statement. Negative 13 equals negative 13. That's true. Since we have a true statement, p equals 6 is a solution because we know the definition of a solution is a value that makes the statement true. So I can say that 6 equal p is a solution. In fact, it is the only solution. All right, you should do all the odds. I'm going to do some of the odds. We have x divided by 19 equals 7. We want to get the x by itself. We have division. To undo division, we should multiply. I'm going to multiply by 19 on both sides. Whatever I do to one side, I must do to the other. 19 divides 19 to leave one x. I just say x. 7 times 19, I believe that's 133. I could put 133 back up there. 133 divided by 19. 133 divided by 19. And that is indeed 7. This statement's true. So I can say x equal 133. Alright, we have v divided by 4 plus 3 equal 4. I want to get the v by itself. I will begin by undoing this plus 3. I will subtract 3. Whatever I do on one side, I do to the other side. 4 minus 3 is 1. We have v divided by 4. Here we have a division. To undo division, we use the inverse operation, multiply. Whatever I do to one side, I do to the other. 4 divides 4 to leave v. 1 times 4 is 4. Let's take that 4 and substitute it back in. So, in place of v, we'll substitute 4. 4 divided by 4 plus 3. Is that equal to 4? That's our question. Is this a true statement? Well, 4 divided by 4, that's 1. Is 1 plus 3 equal to 4? True. Thus, we say v equal 4 is a solution. We'll work one more problem. Let's see number 35 here. Here we have negative 7 times this parentheses. We should distribute, taking negative 7 and multiplying it by both terms in our parentheses. We have negative 7 times r. Negative 7 times plus 9 will be a minus 63 equals negative 63. Solving for r, we will undo this minus 63 on both sides by adding 63. Minus 63 plus 63 is a minus 7r. Minus 63 plus 63 is 0. Negative 7 times some number is 0. Clearly that is going to be 0, but let's show dividing by negative 7 on both sides. We have r is equal to 0. We could take that r equals 0 and substitute it back in, but it will work. This is a solution. All right. Work the odd problems, take a picture of it, and send me the picture. Email it to me. Thank you for watching the video.